Hello everyone, welcome back to another video for the series. I'm Q, and today I brought a problem from USAMO. So this problem, I think it was quite meaningful to me because it taught me a new inequality known as Chebyshev's inequality. So it states that if you have the rearrangement inequality. So rearrangement inequality states that if and if b sub n, then rearrangement inequality states that is greater than or equal to the permutations of these. So we have a sub. Usually they use a different symbol, but they usually use pi. So I'll just use pi too. A sub 1 b sub n plus dot plus a sub n b sub, where if this and that, then where pi sub I will say pi sub n is, no, we use n, right? Then I'll use I. Pi sub I is the ith permutation of 1 to n, where pi of I is the ith permutation of 1 to n. Yes. Now, Chebyshev's inequality, usually in Olympiad, states that so this was rearrangement inequality, and inequality states that n times I equals 1 to n, a sub I, b sub I is greater than or equal to times b sub I. And the reason is because, let's write every inequality status based on the rearrangement. So we know that this thing is greater than or equal to this one because they're equal to each other. This is also greater than or equal to a sub n and b sub 1 greater than, keep writing them until we get Yes. No. And when we add them, we get and add these together, and we get n times a sub 1 b sub 1 plus a sub n b sub n is greater than or equal to a sub 1 plus a sub b sub 1. And that is because we get all the terms. So when we expand this, we get all the terms from here. So if we expand this, it's the exact same thing as adding all these terms. And that's the same for this. So that's why, and that's what the Chebyshev's inequality states. It's like the direct consequence of the rearrangement inequality, and we're going to use it in this problem. So our problem wants us to prove that this is true, where positive reals then we're going to use logarithm here because we know that a, b, c are positive, so it's all good for us to use log. So a, b, c, and this is totally fine because when we look at our graph, if x is bigger, then y is also bigger. So we're going to split them and then use a property. So greater than or equal to, it goes here. So times and let's rearrange them. And notice that this is the exact same thing as the Chebyshev's inequality, because without loss generality, let then notice that n equals 3 here, and a sub 1 will be a sub 2 will be b, a sub 3 will be c here, and b sub 1 will be log a, b sub 2 will be log b, b sub 3 will be log c. So we have them here, and we also have these here, and thus by inequality, the inequality holds, and that proves our inequality. So although the solution for this inequality was quite short. I really love the idea that we could use log here, because even though I tried many inequality problems, it was my first time using log here. And also it taught me how to use Chebyshev's inequality, so that was a very meaningful problem for me. Then I think that was it for today. And thank you so much for watching this video, and please don't forget to like and subscribe. And tomorrow I'll come back with another very fun and interesting problem. Thank you, and see you tomorrow. Bye.